All right, welcome to the ESTA Standards Roundtable. I'm Eric Johnson. I've been working on RDM for a number of years, and I have a couple of other people who will be participating with us in our discussion today. We chose to start with this for our first topic because status and queued messages have been one of the areas of the RDM standard that have been really prone to misinterpretation, misunderstanding, and conflicting interpretations. And certainly there are some holes in the standards document itself. But one of our things today we'll be discussing best practices and how to make, either from the controller or the responder, how to make things work better in a larger system. So, the view of status and queued messages is very different depending on if you are a controller or a responder. Responders only have to do it one way. Controllers have to be aware of all of the different things, all of the different ways that responders might implement it. So, let's start out with a little bit of a discussion of what are status and queued messages and why would you use them. Milton, you want to talk about a little bit about kind of what the basic purpose of status and queued messages are?
The thing that comes with, that I get a lot all the time is just the question of queued messages, and essentially being a method by which a device out there in the world can have some event take place, and because of the nature of RDM, being that a device can't just start talking, it has to queue up a message and wait to be asked to respond. So queued messages in a device can just be queued up in that, and when the controller gets around to asking for those messages, then the device can respond to them. And that can be queued up events, things that have taken place, or status messages like I'm on fire. And that's, I think, where we get into a lot of interesting trouble, because sort of the one function is used for two things. It's used for both status and queued messages built up.
Another problem, another thing where you end up needing to understand status and queued messages is that queued messages are inherently integrated with the RDM concept of act timer. Scott, can you give us a little explanation of what act timer is, how it's used, and why it's needed in the standard?
Sure. So act timer is a way of when a controller asks a device for a piece of information or asks it to do an action, and the device has a very limited window that it can respond in order to maintain the standard DMX refresh rate. So if the device is going to need longer to get that piece of information or to perform that action than what we allow for before it would have to respond to the message, instead of responding back with an actual answer, it can respond back with an act timer, which basically says, I'm going to come back late, I'll have this information for you in this period of time. Typically, it'll say, I'll have this information for you in, half a second or 2 seconds or whatever. Normally, this is way lower than human perceptible time, but it's much longer than what would be allowed for in the standard in order to maintain DMX refresh rate. So when a device sends an act timer message, that tells the controller that, hey, this information will be available, in this period of time, and then the controller can go back and ask that question again. Or a better way is the use of queued messages. The device can put the response to that original request into a queue, which then, when the controller comes around later and asks, do you have any queued messages for me, it can then respond with whatever data, whatever message it has to send back. So this can be a request that was act timered, or it could be any other type of action, any other piece of information that the device, wishes to inform the controller of. For example, if the user goes up and changes the DMX start address on the front panel of the fixture, the device would want to send that information back to the controller so it can queue up a message and have it available the next time the controller comes around in a round robin asking everybody if they have queued messages to report.
So let's be clear about one thing, particularly on the responder side. A lot of embedded developers hear the word queue, and the first thing they think is, I don't have enough memory to do a queue. So one thing we should be clear about, you don't actually need a queue to do queued messages. Generally, all you need is 1 bit of storage per thing that you can report. You just need to track that I need to report a DMX address change, or I need to report an over temperature event, or I need to report this. You don't actually have to queue up full RDM messages. So if you have, 7 different things that you can report, usually you get away with that with just 7 bits of storage. Now, one of the best practices for queued messages status and queued messages that we'll get to later is that you should report an outstanding ACK timer first, just for responsiveness of the system and to cut down on some ambiguities as far as what queued message matches to which request. So, if you're hearing queue, you don't actually need a lot of memory. Like I said, if you have 7 things you can report, you can usually do it with 7 bits. If you want to do the prioritization, you can do it with 14 bits. Even the most limited devices can usually scrape 14 or 15 bits off the wall to get where they're going. So let's start out with what's the difference in a status message and a queued message. And it really comes down to one thing. A queued message is a way that a responder can report a change in something that has an RDM PID associated with it.
A setting.
Yes, an RDM parameter, an RDM setting associated with it. So things like, as Scott mentioned earlier, my DMX address changed. My personality changed. My lamp hour just increased. My lamp just went from the running state to the off state, aka I blew up a lamp. Anything that has an RDM, a parameter is an RDM, a PID is an RDM parameter, is a thing that you can set, will be reported via a queued message. A status message is for things that don't have PIDs associated with them that are informational. The thing about status messages is that they're largely intended to be human-read, whereas queued messages, because they follow the data structure of an RDM PID, are intended to be machine interpreted. It can say that, hey, my lamp hours just increased. Oh, I can go off to my GUI, take an event, and update the lamp hours. Or notify the console operator that, hey, a DMX address just changed. Simon, do you want to talk about a couple of things that are frequently reported via status messages? These are not as structured, really intended to be read by people.
Sure. So if you look at the standard, there's a bunch of statement histories there, and they cover all sorts of things like sexes, changing values, and events such as like a color failure, that type of thing.
Yeah, there's a lot of things that you would normally expect: breaker blown, dimmer over temperature, load change. The sort of things that people are used to getting back from reporting fixtures, and that would often show up on a fixture's front panel. The thing about RDM is it really allows you to do the things you used to have to walk to the fixture to do. And so it can say air filter clogged, fan failure.
Fog fluid low.
Exactly. Things that are not structured data. So most of the time, unless you have a natural language interpreter, most controllers will just take the output of a status message and display it to the user in some way. Except there is data included with each status message that tells you its severity. Why is that important? Because you have errors that you probably need to know about quickly, and you probably want to notify the user about. The convention is usually that an error is something that would affect the look on stage. Your performer isn't going to look right. The queen is going to be in dark. You need to know about this. And so there are different levels of, we have error warning and informational, I believe, are the levels that you can report.
Error warning and advisory.
And the standard gives you ways that you can filter out and only say, I only want errors. During setup, during load-in, you might want everything. During a show, you probably want to filter out the stuff to only the stuff that's going to affect the look on stage. So those are the real fundamental difference between status and queued messages. Queued messages are RDM PIDs. They are structured to be machine readable, and the console, the controller, whatever it is, can take action on them.
I think it's also worth noting, because you're talking about data that comes back with the status messages, there's also 2 other data value slots that are in each status message that can be used to pass back context relative information. So, for example, if the status message is an overtemp message, then the string would be sensor, number X is overtemp at X degrees Celsius, and it can pass back for that message. It's defined, you pass back the sensor number and the temperature, so you can then present this to the user in a human readable form that actually gives them something other than, there's an over temperature somewhere. It actually tells you what the temperature is and where it's at. Or if you've got a phase that's over voltage, you can pass back, the phase number and the voltage, for example. Or on a moving light, a really common example is if, the color wheel doesn't home properly, you can basically pass back that, the color wheel slot fails homing. So this helps give the user some real world information then.
So whenever possible, we try and standardize on certain messages. We ask people to reuse existing status messages as much as they can, because there are standard status messages that do give the option that the computer might be able to react on it automatically. Simon, were you pulling up the list of the standard status messages? Do you have that list in front of you right now? Okay. So, however, there's a lot of status messages. So we've actually set up so that on the ESTA website, there are additional status messages defined. If you're a controller manufacturer or a fixture manufacturer, when you're releasing new firmware versions, go ahead and check the ESTA website on the RDMs, on the Control Protocols Working Group section, because there are always going to be new status messages, new standard status messages that are being defined. And whenever possible, it's better to reuse existing status messages than to define your own. Sometimes you have to define your own. Our usual joke is dimmer room flood and dimmer on fire. Apparently we have a biblical disaster going on in this dimmer room. I don't know what happened. Maybe they were doing a production of the Scottish play and somebody forgot all of the superstitions associated with that. Now, in this part of the standard, there have been some areas that have really had different interpretations. And Scott, I think I'm going to turn to you for this one. As we mentioned repeatedly, queued messages are intended to be machine interpreted. But they're also tied in with ACT timer, because the responder can send you unsolicited queued messages.
Right.
The responder can send you, my DMX address just changed, something happened. But also, they can be used to fulfill an ACT timer. You said, what are your lamp hours? The fixture said, I can't get back to you for 100 milliseconds. You waited 100 milliseconds. Now it's sending it back to you via this. This was originally intended to work with basically things that took too long. You had to wait for an access to home. You had to wait for something that took mechanical time. But the way it's largely actually being used today is by the people who run proxies. So, Scott, could you talk a little bit about how a proxy uses, an RDM to RDM proxy uses ACT timer as part of getting messages across the link where the latency is higher than we can stand?
Sure. So first off, let's explain a little bit about what a proxy is. A proxy is basically a specific class of inline device that we had envisioned back in the early days of RDM. Now, in many cases, we had envisioned proxies as being a managed RDM splitter that's doing, a lot of complex stuff in it. But in reality, what is most of the proxies that are on the market today are actually wireless systems. So I've got a, DMX and RDM input box, which is in the wireless transmitter, which sends the messages across wireless to a fixture that has wireless receiver in it. So because of the message, whenever I send a request, it has to go from physical DMX RDM message on the RS-45 wire, be converted into a wireless message that goes over the air, and then received in a wireless card, where it typically gets converted back to an RS-45 DMX RDM message internally in the fixture, and then the fixture has to receive and respond to that. Well, obviously, all those steps it's going through takes a bit of time.
And we only allow 2 milliseconds for a response.
Right. So most the only real way that wireless systems can function is by making use of the proxy facility that we put into the standard, which allows for basically use of ACK timer. There's also some other specific messages related for proxy devices as well to help with discovery and things. But really where you see the most use of the proxy features is the use of ACK timer. So basically every message, if you're using a wireless system, every message that the controller is asking the moving light of the device, you know, the other side of the wireless link, will involve ACK timers while it's retrieving the data. So the transmitter will typically send a ACK timer back for every request the controller sends. The wireless transmitter will send an ACK timer back to the controller while it goes and fetches the information and collects it back to have later.
Nice, Simon. Could you walk us through an ACK timer sequence? You know, what happens when, with a proxy involved? You know, the controller sends the request, and then what happens from there, from the controller's perspective, and what happens from the respondent's perspective?
Sure. So let's say we have a controller with a wireless link, and a responder sitting on the other side. The controller will send, let's say, a get DMX start address. The proxy receiver will get that, or the proxy transmitter, wireless transmitter, will receive that, immediately turn around with an ACK timer and send that back to the controller. And in the meantime, it will send that get down the wireless link to its wireless receiver, which will then pass it on to the responder. The responder will see, as normal, a get DMX start address request, and will reply, hopefully, with a DMX start address get response, with its current start address. And then the wireless receiver will send that response back to the transmitter, and the transmitter will buffer it there. And so when the controller comes around next time and says get queue message, the wireless transmitter will have that response buffered and will reply with this is the get DMX start address response that I last received.
And this brings us to one of the first common mistakes in RDM in queued and status message implementation, which is the recognition that just because something was ACK timered, it can still be NACKed later on. The case that Simon just walked through, the proxy received the request. It ACK timered it because it needed time to get the real answer from the responder. The responder can then NACK it, and because it doesn't support that PID, or it was bad request, or something like that. And so then the queued message that you will get in response is a NACK of what was previously ACK timered. And this can actually happen chained, because there can be chained proxies, or the end responder may actually have to ACK timer to get the real answer. So you can send a controller, typically a console or some sort of test equipment, so it can send a get or a set. It can get an ACK timer. It can then get the queued messages, and the queued message is another ACK timer, which then you get that queued message, and then you get a NACK. How long can this go? The RDM standard supports up to 4 transparent inline devices, but there is no limit to the number of proxies. Realistically, if you have more than one, it's probably time to redesign your system. But in some unusual cases, you can see multiple chained ACK timers, and controller implementations should be able to handle that, or you will see implementation issues in the real world.
Not to mention latency.
So Milton, I know that I think you've commented in the past that this is one of the dustier corners of the standard for you.
Yep.
That every time you have to deal with it, you got to reread it, and you come out. What have been the areas of concern and question for you? And what do you wish what do you miss?
One of the biggest things for me in implementing is when I have a status change, for example, a burned out lamp. I say that I've got a queued message waiting, and the controller comes along and
Queued message or status message?
Status message. And controller comes along and says, okay, give me your status message, and I report it. then that status is cleared. Well, my lamp's still burned out.
Right.
So every time the controller comes around and asks me, you know, what's your status? Do I report that my lamp is burned out? Yes or no? According to the standard, no, I don't report that the lamp is burned out because I've already reported that.
Yep.
But that's something that I've gotten questions about.
Sure.
A lot is, why shouldn't I report my status as lamp burned out?
So let's,
it still is.
And that's actually one of the common, actually it's called a weakness in the standard.
Yeah.
And we'll address a little later some of the difference between the original 2006 version of the document versus 2010. Status messages are asserted. Dimmer on fire.
Yep.
But they're only asserted once. What if it was asserted right at the end of the night during takedown to a console that got unplugged, put on a truck, and is currently halfway through North Dakota, notifying you that your dimmer is on fire? Probably not the best example, that your lamp is burned out. What do you do? Because the responder thinks it's already reported that status, but the house console doesn't know about it. Generally, the best practice is that that a responder should repeat status messages as long as they are still occurring in proportion to the severity of that status. Gnat flying through the beam, report it once a month.
Yeah.
Breaker blown, dimmer on fire, dimmer room flood, you probably want to report that every minute or so to make sure that it gets through to the console. Now, most consoles, they might notify the user, they might drop it in a log file, they might put an icon up on the screen. So you need to be mindful that you don't want to flood the user with tons of status messages. But if they need to know about it, they need to know about it.
And that's largely dependent on the controller and how often it's looking for status.
How often it's looking for status? And there's really no standard. I mean, when you look at consoles, how often do they collect queued status messages?
Anywhere from, you know, once every few minutes to 10 times a second.
Yep. It varies widely, and you never know how much they're going to come in. The other thing is that the original version of the standard, you could assert a status message, but you could never notify that, hey, this is no longer a problem. Somebody reset the breaker. Somebody got a fire extinguisher. We're talking about this. You shouldn't actually use status messages to report a dimmer on fire. That's probably more for your life health safety systems.
But it is actually worth noting that you can define manufacturer-specific status messages. You're not limited to the ones that are publicly defined. We try to define publicly defined ones so they'll be common across, you know, a wide range of devices. But if you have a device that has some, you know, unique properties, unique status pages that wants to report, you can define your own and report those.
And this is a cool thing that isn't inherently obvious to the first-time implementer or user, is manufacturer-specific status messages does not mean that manufacturer X fixture has to be used with manufacturer X controller.
Correct.
Status, the manufacturer defined his are self-defined elsewhere in the standard, so that the fixtures, let's say, can report all of its manufacturer-specific things to the controller. So a controller that has never seen that brand before, never seen that kind of fixture, can present you with status information that is very specific to that kind of fixture if they've chosen to define it.
In a human-readable format.
In human-readable format, yes.
Dimmer room, floor 3, flood at 7 feet.
Build an arm.
Exactly. So you can assert that a status message, that a status condition has occurred. The original version of the standard never had a way to say, that's not a problem anymore. The 2010 version of the standard added a status cleared, so that you could say that, oh, hey, this occurred. When it's fixed, you can say, this has been fixed. It is now status cleared. The controller asks for, give me your errors, give me your warnings, give me your informational. And then the responder can say, I am asserting an error or I am clearing an informational. You don't ask for cleared status. You ask for a severity level, and then it tells you, here's what I'm asserting, and here's what I've cleared.
Now, if you ask for a error, but if you're only asking for errors, filtering by errors, you're telling the device, only tell me about errors, then if you have any error cleared, you will get those. But in that case, you would actually not get the advisory cleared.
Correct.
You would only, or the warning cleared. You would only get the cleared messages relating to the severity level requested.
And severity levels are cumulative. So warning will give you errors and warnings.
Correct.
But not informational. But error will only give you error. And if you collect informational, it will give you all of the above. The other thing to know is that with queued messages, which are the standard RDM PIDs in machine-readable format, there's one per response. But status messages can be packed many into a response. Now, something for developers to be aware of. Generally, we try and keep RDM messages short because we don't want them to interfere with the crossfade. Even though you can return tens of status messages in the same packet, in the same response, doesn't mean that you should. And actually, this was one that was discovered by Peter Willis. Generally, I mean, barring, if you're reporting a ton of errors, you're probably going to have crossfade problems anyway. But generally, it's best to report a handful of statuses at a time. Don't pack the message completely full because you don't want to interrupt an ongoing crossfade. Most systems with short RDM messages and well-behaved responders can interleave RDM with ongoing null start code DMX without visual artifacts. Barring some of the most extreme direct view kind of video wall applications, you can usually interleave it without any visual artifacts whatsoever. But this is one of those rules. Normally, your controllers try and schedule when they do long packets when there's not a crossfade active. But with this case, you send status messages, you could get none, or you could get a maximum length packet. So responders, try and avoid doing that whenever you can. Now, Bob, do you want to, when you've looked at this part of the standard, what have been the things that have concerned you? Or
what's always been having to go look again to see it, is to realize that when you ask for a queued message, you have no idea what you're getting back. All of a sudden, you ask for a queued message, and a packet comes down telling the start address and the dimmer has changed. But you don't, so this is a case where the rule that the outgoing PID and the returning PID match. No, they don't. And the returning PID is the only is a completely, from the controller's point of view, until it reads it, it's a random event.
And this is one of the dustier corners of the standard. Not only can I say get queued message, and it comes back with get DMX personality, you can also do get queued messages, and if there's no queued messages, it returns a status message. Why? Because it allows a controller to pull responders with one message. You can do a get queued message, and you will get both queued and status messages.
Otherwise, we'd have to do two. So if I first have to pull every device in my system asking for a queued message, and then I would have to go around and pull every device in my system again to ask for status messages. So by folding it in where you can get the status message back if there's no pending queued messages, it basically cuts the round robin time in half.
You also get the bizarre one of giving you status none. Just you asked for status message or you asked for queued message, there wasn't one. You asked for status, the queued message, there wasn't one. It sends back status none.
Correct. It sends back, well, you can ask for, when you are doing a get status message, you put in the request what level you want. You can say, I want errors, I want warning, I want notice or informational. And then you can say status none, which is what Bob is talking about. And then there's also a get last, which we'll get to shortly. Status none basically means, I just want to know if you're alive and responding. Don't actually send me status. I want to know how you're feeling, but I don't care about the response. I think we've all had stage managers like that.
It's the equivalent of a ping.
It's a ping. It's an are you there? It's an are you still on the line and responding?
Although at the same time, it's worth just noting that this is not a required bid for a responder.
It is not. A responder does not have to implement status messages.
Right.
It does not have to implement queue messages.
But doesn't it have to implement status none?
Nope.
I thought having status none does not mean that you support status messages.
No, you can respond to a get queued messages with a status message of 0 length, but that does not mean you support status messages.
Okay.
There were some devices, some companies early on that did not feel that they had the space or the want to implement status messages, the need for status messages. So while they are coupled together in some respects, they are decoupled in the sense that they are still optional.
So a responder that doesn't want to deal with any of this doesn't have to.
Knack it.
Knack it.
Yep.
It's up. If your customers need it, they'll call you.
Still allows it to be used as a ping because a knack is a response.
A knack is a response.
Yep.
It means you're on the wire and responding.
Yep.
But controllers effectively have to implement queued messages and really do need to implement status messages. It's a core part of the functionality. It's generally assumed that a controller is more, it's not always true, but a controller is more resource rich than a responder. And if controllers don't implement queued messages, you will break in the proxy situation. You will break in other things. And it's effectively mandatory for all but the simplest controllers.
And a good majority, I would say, of the devices out there do support status and queued messages.
Yeah, definitely.
And they add a lot of value to the standard. They add a lot of functionality. Just because they are optional for a device to implement, doesn't mean that it's not a really good idea that you should support it, because it will just make your device look that much better in terms of the functionality level that you get.
So we talked on get last briefly. Simon, do you want to talk through why get last is there and what its implications are?
Sure. So the problem that get last is designed to fix when the controller sends a get status message, and then it's not getting in return, or maybe it gets a null response in return. As a result of that, if you didn't have get last, the responder would think that it's handing off those status messages to the controller, but the transfer of information from the responder to the controller is not actually successfully occurred. So in the event that a controller asks for a set of status messages and cannot understand the response, it can reissue that same request with status get last, and the responder will send it the contents of the previous response.
And what we need to say here, RDM is an unreliable protocol. There's no guarantee of delivery. Anything can drop any packet at any time for any reason or no reason at all. Cell phone got too close to the cable, noise, bad software implementation, timing problems.
Microphone cables, unterminated lines.
You name it. So any time that a controller asks for a status or queued message and doesn't get a response, it doesn't know if the responder never got the request, if it got it and responded with something critical. Because once a message is delivered, it's only delivered once. This is a way of basically saying, send me what you sent me before. But what this means is that once you do a get status or queued messages, until you have successfully delivered that, you cannot ask for another one. Because if you ask for another one, you've lost the one that was potentially in flight. So if for any reason, if you don't get a response, if you get a corrupt response, if you get data that doesn't make any sense, you need to use get last to get that data. Otherwise, you've risked dropping some bits, potentially critical bits, on the floor.
And this is the reason, the reason we have this here and really not anywhere else is because every other thing in RDM, you can always just send a get request and get it again. So
or a set request.
Or a set request. So if I ask for the DMX start address or something in the lamp hours and I don't get a response back, I can just ask again. But with status messages, and queue messages, if I ask again, That basically, means that the device interprets as meaning that it got the previous one okay, and it's asking for more. So this is basically the one place where we have, volatile data that can go away, that we have to make sure, there could be a second chance or a third chance or a 25th chance to try and retrieve it. So as long as the controller keeps sending get last status, then the device just keeps trying to send back that same one again.
Yeah, it comes down to the get data sending requests, so not right?
Yeah, this is not really designed as a database. There's, an ACK doesn't necessarily mean that it's an EEPROM. This is more kind of human scale stuff. But this is one where it's machine-to-machine communication of critical data, and we need to make sure that it gets through. This requires some testing. I often see problems with consoles that receive a get last having not delivered any messages. Make sure your initial conditions are right. Look for uninitialized variables. I've seen some really weird things when you do a get last, having never seen a get queued messages or get status messages.
What is the appropriate response to get last when you do not have a last?
My response, is that you should return an empty zero length, zero PDL response. That is not in the standard anywhere. It's just my interpretation.
But you certainly do respond.
You absolutely respond. You just respond with a zero length status message.
With no status messages. You basically respond that you have no messages to report.
Another thing, so we've talked about how you can assert messages, you can clear messages, but you never really know what consoles have, what's been delivered to what console where. There is a message in the standard, clear status ID. The text of what clear status ID does is unfortunately not very well written. And Scott, do you want to read what it actually says clear status ID does?
Well, yes. This parameter is used to clear the status message queue.
Thank you. Frobnobulator mode. This bit sets the frobnobulator mode.
Yeah, it's like reading, the setting information in for any setting you look at your computer BIOS. This setting sets blah.
So
at the time when we wrote it, it all seemed pretty obvious. We all thought it was obvious. It wasn't until it got out in the wider world that we realized only those of us in the room that had discussed it for many hours at length are the ones that understood what it was meant to do.
What this message is supposed to do. Milton, did you want to take this one?
No.
Okay.
So what does it?
It is supposed to wipe any status messages that have not been delivered and reassert any status conditions that are still present. So,
The second part is key.
That second part is key.
Yeah.
If there are status messages that don't exist any longer, I don't need to know about them. I don't care what happened in yesterday's show. I want to know what happened. Forget what you haven't told me. Tell me what problems you have right now. I don't care that you had a crummy day yesterday. What's wrong now? Where are you bleeding?
And the classic example of this is, if you're doing a theatrical show with a dimming system that does load monitoring, and you're loading in a new show, and the system has all the loads recorded on each dimmer channel for the previous show, you're going to get 1,000, load change messages because nothing matches anymore, and you're basically going to walk up to the console, staring at 1,000 messages trying to pull in, and you realize that it's all garbage. So this was basically just a fast way of flushing everything out of the system, and so you can start clean.
Most consoles at boot, I would say, should issue this request before they start collecting status messages, because this should ensure a clean start. This is not universal. There is some work to further clarify this. The other thing is that this has been discussed at length on the RDM protocol forums. It's a resource for RDM developers. If you haven't found it yet, you should.
RDMprotocol.org.
RDMprotocol.org. The signal-to-noise ratio is very high. Unlike most forums, it is not full of people asking desperate questions with no answer. There are a lot of qualified people who answer questions and good technical discussions. If you haven't found it yet, please find it. It will save you and everyone lots of headache. And if you have questions, feel free to post them. There are no trolls. There are no internet denizens. It's a very good signal-to-noise ratio, and we think you'll end up with good technical answers, usually within a day or two.
Yeah, normally we try to, whenever somebody posts a message on there, it basically is an email out to a number of us on the task group. So it is exceedingly rare that you will not, that you won't have a response within, at least a few hours. You'll typically have a response, and then you'll get, responses from other people within the next day or so also.
So
Now, I have one question.
yeah, Bob.
You say that this clears all the outstanding statuses, but you then said there is no status queue. I mean, no.
There is a list of things that need to be reported, but it can be a bit masked. It can just be I need to report dimmer over temperature, I need to report this, I need to report that, I need to report the other. You're not actually queuing up fully formatted messages.
You could. It's up to you.
But it doesn't require it, at least since I think that was something that needs to be clarified. I also have one other thing for Scott to clarify, if he would like. Okay, the common misconception with proxies is if I only had a fast enough radio receiver, I wouldn't have to use the status messages. But, as has been pointed out, structurally, you can't decode the DMX device, the RDM packets, and resend them fast enough. Is that correct? That regardless if I essentially put light speed link between those two, I'd still end up with the RDM requiring you to use proxies.
Yes, for one reason. The controller sends a request, it goes through a proxy. The responder has 2 milliseconds to respond. The responder at the far end could take the entire amount of time that is allowed, leaving no time remaining for the inline proxy to get back.
You don't know how long the device at the far end is going to, the device, the moving light that's got the wireless card in it, it could take almost the entire 2 milliseconds before it responds to the request to get back to the wireless receiver. And then that has to go all the way back over to the wireless transmitter, which then also needs time to send back. So you can end up with a round trip time that starts stacking up.
There's one final area that we should address, and that has to do with subdevices.
Oh, yes.
Get status and queued message are only sent to the root device. You can get responses from subdevices that are attached to that responder, and they come back either with a queued message, it comes back in the RDM packet subdevice field, or for a status message, it's part of the stacked repeating block of status messages. There's the subdevice that it's in the repeating block. There's the subdevice that it's associated with. There's the severity. There's the 2 data values, and there's the status ID code. So I can send a get status message or get queued message to the root device and get status messages for any number of subdevices and the root. And I can send a get queued message to the root and get queued messages from my subdevices. But these are only sent to the root device. That is often missed and can cause interoperability problems if you don't follow.
Yeah, what was Wayne's example? Wayne had a good example earlier today.
If the console is only collecting from the root device and the responder is expecting you to collect from the subdevices, you will never see status and queued messages from your subdevices.
And per the standard, you're not allowed, the controller is not allowed to send it to the subdevice. It is only allowed to send the request to the root device.
So, there's a reason that we've referenced this as the pitfalls and pratfalls. There are some dusty corners. There are some things that can be a little confusing. We're hoping that, most of this talk is targeting technically advanced users, system integrators, and developers. We're hoping that you've been able to pick up some understanding of how this works in the system, what it does, and how to make it work better if you're implementing a system. Some of these best practices have been hard learned, and hopefully we can make things easier for everybody going forward. I think I'll do one final around the table here. Scott, is there anything that we've covered that we haven't covered that you wish you'd known about status and queued messages when you've been doing your implementations?
Nothing that I can think of off the top of my head. We've covered all of the some of the major holes, I would say, that people fall into, and a lot of major places where questions pop up. I think we've covered here today.
Simon, where do you see this going wrong?
No, I think this is about it. I would note that the whole situation gets a lot more complicated when something like RDM is introduced, either RDM or RDM over RDM. But you can leave that for another session.
Okay.
So that is almost a whole other talk on its own, isn't it?
Doug, did you want to pipe up at all?
No,
All right.
glad to be here. Hello, everybody.
Hey, Milton.
And for me, my major thing was I wish that the 2009 edition had been out when I first did queued status messages, because this whole thing of sort of edge triggering of
Right.
errors was a big source of confusion for me. So I'm a lot happier with where it is now.
Okay. Great. Bob, anything that you want to add to the?
Not particularly, other than we've gone over the places. It is a little bit baffling, sometimes just to keep it straight, because, when queued messages bring back status messages, it's sort of against everything that RDM has mostly done. It really is a special case scenario.
RDM is really intended to be machine-to-machine communication, and we're doing things that are really intended to be human-interpreted with status messages. And that sometimes takes a little bit of understanding. This isn't just your fixtures and your console talking. This is you having to think about how you present data to the user and how you give how do you give a good user experience.
I think the one point that is worth making, what Simon kind of referred to, one important thing I think to note is when you're trying to do RDM over ArtNet is where you have a particular problem with status and queued messages is if you've got multiple controllers out there doing it, because as we talked about before, the device only sends the information once and then flushes it. Once you have multiple controllers, and in ArtNet over RDM over ArtNet in particular, you can end up with multiple controllers, each one asking the same questions. So each controller will basically kind of get, not a full picture of what's really going on, because if controller A requests status messages and it gets them all, when controller B asks half a second later, it's not going to get anything, and vice versa. That maybe something else pops up. Controller B will get part of the picture, controller A will have part of the picture, but nobody has the full picture of of what your the current state of the system. And that's been one of the big challenges in RDMNet, is actually addressing the multi-controller world that we're living in now.
I'm sure we'll be doing a number of discussions on that, both at the trade shows and probably a future roundtable discussion.
Yes.
Alrighty. Well, thanks everybody for participating today. Hopefully this will be educational. Hopefully both anybody who's watching remotely as well as those who are watching the recording. Hopefully this has been educational. We mentioned some of the other resources that are available to you in the rdmprotocol.org website. The plug fests, which occur regularly both in the UK and in the US. We really try and make resources available to developers, people who are working with RDM to build products and integrate systems, to make sure that the knowledge is out there. One great thing about the entertainment industry is that this is a pretty small industry. We can share knowledge, and there's a lot of highly qualified people who want this to succeed. So,
do you want to see if there's any questions? I see Gary online in particular.
Sure. Yeah, looks like we have a minute for anybody to submit questions via the chat window or via the audio. All right. All righty. Well, with that, I'm going to go ahead and end the session. Thank you very much.
Thank you, Eric.
And break a leg.
Or,